Right. So we are going to start the new lesson, factors and multiples. So before going to the lesson, write down the heading, factors and multiples. Right. Okay.
Yes, teacher.
Right. Then first tell me, I think you know how to find a number which is divisible by 2, then 5 and also 10. Do you know how to find a number divisible by 2, 5 and 10? What is the method? Do you know the method?
No.
No. Then we'll see how to find that. Examine whether a number is divisible by 2, 5 or 10. Right? Note down this one also. Then I'll explain how to find the numbers are divisible by 10, 5 or 10.
Okay, teacher.
Right. It is easy for me if you can switch on your camera.
Okay, teacher.
All right. Now okay. Right. Look at this one now. If the ones place digit of a number is divisible by 2, then that number is divisible by 2. The next one, if ones place digit of a number is either 0 or 5, then that number is divisible by 5. Then last one, if the ones place digit of a number is 0, then that number is divisible by 10. I think you have already know this. Right? I'll explain how to find that. Consider these numbers. Right? Look at the board now. Right? Think these numbers. 252, 378, 50. Right? Check with the unit place value. Here, unit place value is 2. Here, unit place value is 8. Here, unit place value is 0. Now, how you can check whether is this number is divisible by 2? What you have to do?
By looking at the last number is divisible by
Yes.
2.
Last number means ones place value. You have to check whether is that divisible by 2. How you can identify a number is divisible by 2? If that number is 2, 4, 6, 8 or 0, then that is we can divide by 2 without a remainder. I think you already know.
Yes.
Right. So if the last digit or the unit place value is divisible by 2, then that whole number is divisible by 2. Is that okay?
Yes, teacher.
Do you know to write down the examples?
Yeah.
Then write down, first write down this one. This one. If the ones place digit of a number is divisible by 2, then that number is divisible by 2. Here, this should be separate. Is number is divisible by 2, then write down the examples. When you are finished, tell me. Right? If you have finished first sentence, then you have to write down the examples. Let me know.
That means, teacher.
First sentence, have you finished this one?
Yeah.
Then write down these examples. These are the examples.
One, teacher.
Right. Then we'll see next one. If the ones place digit of a number is either 0 or 5, then that number is divisible by 5. I think no need to write the examples. Here also I write examples. Right, okay?
No.
Okay. Right, shall we move to next one?
I like the third one.
All right, okay. Then examples I'll write here.
Okay, teacher.
Right, then we'll move to next one. Have we note down the examples also?
Yes.
Okay. Now we are going to learn what is the digital root. Have you heard before?
No.
No. We'll see what is digital root. Write down the heading. Then I'll explain.
Okay, teacher.
Right. Right, look at these numbers. Three hundred and 26, right? Now we are going to find the digital root of these. So what we have to do is, we have to add all these numbers together. 3 plus 2 plus 6. What is the value? 3 plus 2, answer is 5. Then 5 plus 6. What is the value? 11.
11.
So again what we have to do, again we have to add until we will get a value as 1 digit. Okay. Now we have 2 digit here. Then again I have to do is add these two numbers. Then how much? Answer is 2. So this is the digital root of 326. Got the idea?
Yes.
Right. Write down this one as example.
Okay, teacher.
Right, we'll see another one. Right? Okay, I'll give another one for you. This one. You have to find the answer alone. Then I'll explain. Right.
Done, teacher.
Right. What is the answer?
1.
1. Yes. So you have to add all these numbers together. 1 plus 0 plus 2 plus 7. Then 1 plus 0, 1. 1 plus 2, answer is 3. 3 plus 7, answer is 10. But we have to find the answer as 1 digit. Then 1 plus 0, again answer is 1. Then the digital root of this number is 1. Okay, have you got the idea now?
Yes, teacher.
Right. Then we'll move to the next part. Right. Examining whether a number is divisible by 9. Note down the heading, then I'll explain. Right. Okay.
I know, teacher.
All right.
Okay, teacher.
Right. Now you need your textbook. Right. There is an activity there. Here, activity number 1 in your lesson. Complete the following table and answer the given questions. Right. First one, I'll do with you. Right. First one, number is 45. Then they are asking digital root. So how you can find the digital root of that?
4 plus 5.
Yes, 4 plus 5. Answer is 9. Right? Digital root is 9. Remainder when divided by 9. 45 when you are divided by 9, is there a remainder?
Yes.
How much?
No.
No, no remainder. Then we can put this one as 0. Okay. Then is the number divisible by 9? Huh? Is that divisible by 9?
Yes.
Yes. Then up we right. You can put a tick here, right? If it is divisible by 2, you can put a tick. If not, you can put a cross. Is 9 a factor of 49? Do you know what are factors?
Teacher thought of it, but I couldn't understand.
Factor means if a number divisible by another number. Think you have the value is 4. Can you divide 4 by 2?
Yes.
Yes. So 2 is a factor of 4. Then can you divide 4 by 4?
Yeah.
Yeah. Then 4 is also a factor of that number. Understand?
Yes, teacher.
Number 18, what are the values we can divide that by without remainder? If I consider 18, right, I can divide this by 1, then by 2, then by 3. Can I divide by 4? No. Then 5 can't, 6, yes we can, 7 can't, 8 can't, then 9, then you can have the value 18. So 1, 2, 3, 6, 9 and 18. All these are factors of number 18. Okay. Right. So is 9 a factor of 45? Yes. Because we can divide that value without remainder by 9. Right? Okay.
Okay.
Right. Here also you can put a tick. Right? Then remaining question can you do now?
Yes, teacher.
I'll give 10 minutes, complete the table, then we'll discuss, right? Okay.
Teacher,
Just tell me.
when we get 52, again this part is 7, no?
Sorry, digital root is that number. Yeah, is that you are asking?
No. In your example, 326, and becomes when you add them, it becomes 11, 2
I
digits.
can't hear you clearly.
This one is like 2 digits to add now.
549.
No, 52.
52 years.
It doesn't have 2 digits.
Digital root is how much that number?
7.
7. Remainder when divided by 9. Is there a remainder?
1.
Yes. Is the number is divisible by 9?
No.
No. Then you have to put cross there. Is 9 a factor of that?
No.
No. Then you have to put cross there. Okay.
Okay, teacher.
Then do next one.
Then, teacher.
But shall we discuss the answers then?
Okay, teacher.
Okay. Next one. 134. What is the
8.
digital root? 1 plus 3
8.
is 4. 4 plus 4, 8. Then they are asking remainder when divided by 9. We'll see. 134 we have to divide by 9. Right? For 13, how many 9s are there? 1. 9 into 1, 9. 13 minus 9. How much?
6.
6. Then for 64, sorry. 9. 13 minus 9, 4. Then 44. How many 9s are there? 4. Then 36. 14 minus 6, 8. Then remainder is 8. Is the number divisible by 9?
No.
No. Then is 9 factor of that number? No. Right? Okay. Then next one. 549. What is the digital root? 5 plus 4, 9. 9 plus 9, 18. 18 means again 1 plus 8. Answer is 9. Then digital root is 9. Remainder when divided by 9. 549 shall we divide by 9? For 54, how many 9s are there? 6. Then 54. Then we have to take 9 for 9, 1. 9 into 1, 9. There's no remainder. Then remainder is 0. Is the number divisible by 9? Yes, that
Yes.
is correct. Then that is a factor of 9. Right? Next one. 1323. What is the digital root? 1 plus 3. Answer is 4. 4
9.
plus 2, 6.
9.
Plus 3, 9. Then all together answer is 9. No? Then digital root is 9. Remainder when divided by 9. We'll see. 1323 we have to divide by 9. For 13, 1 9s are there. 13 minus 9, 4. 42. How many 9s? 4. 9 into 4, 36. 12 minus 6, 63. How many 9s are there? Not 8, 7. Answer is 7 here. Right? Then remainder when divided by 9, 0. Then is that number divisible by 9? Yes.
Yes.
Then is 9 factor of that number? Yes. Next one, 1254. 1 plus
12.
2, 3. 3 plus 5, 8. 8 plus 4, 12. Okay. 12, then 1 plus 2. Digital root is 3. Remainder when divided by 9. We'll see. For 12, 1. For 35, how many 9s are there? 3. 27. 8. For 84, 9. 81, remainder 3. Right? Then remainder is 3. Then is the number divisible by 9?
No.
No. Then 9 is not a factor of that number. Next one, last one, 5307. 5 plus 3, 8. 8 plus 0, 8. Then 8 plus 7, 15. 15 means again 1 plus 5. Then digital root is 6. Remainder when divided by 9. Sorry, 9 to 5. For 80, how many 9s are there? 8. 72. 10 minus 8, 2, 8. For 87, 9. 9 into 9, 81. Remainder is 6. Right? Remainder is 6. Is that number divisible by 9?
No.
Then 9 is not a factor of that number. Right? Then we'll go through the questions what they have given. Question number 1. What are the digital roots of the numbers which are divisible by 9? In other words, the number of which 9 is a factor. What are the digital root of the numbers which are divisible by 9? We can identify here only if the digital root is 9. Here, that number is factor and also divisible by 9. Have you identified that?
Okay.
Yes, this one also here. If digital root is 9, then that is divisible 9 and also that is a factor of that number. Then this one also same. Right? Then using your answer to the previous part, suggest a method other than division to test whether a number is divisible by 9. What can you say? Now without dividing, we can find the number is divisible by 9. How we can check? Here, if the digital root is 9, that number is divisible by 9. Got the idea? Here,
Yes.
if the digital root is 9, that number directly we can say we can divide by 9 without remainder. Okay.
Yes, teacher.
Right. Then we'll move to next one. Here. Final decision is if the digital root of a whole number is divisible by 9, then that number is divisible by 9. And also that is a 9, we can say 9 is factor of that number. Okay.
Yes, teacher.
Right. Write down this one with another color pen also, or you can highlight that. Right. You have to remember this one.
Then teacher.
Right. We'll move to next one then. We'll move to exercise. Here exercise 4.1, without dividing, select the numbers which are divisible by 9. Right? Now how we can check whether? Huh? How we can check whether that number is divisible by 9? Now we are not going to divide. Without divide, we are looking at that number and we have to find out is that divisible by 9 or not. How we can check?
By saying the last digit is divisible by
No,
9.
not last digit. Now digital root, no? We learned that no before. Here 504. I'll do first one for you, right? 504. So we can find the digital root. What is the digital root? 5 plus 4. Digital root is 9. Then this one is divisible by 9 and also a factor of 9. Okay.
Okay.
Then this is divisible by 9. So you have to check with the other numbers also. This is easy for you. You can insert this one into a table. Write the numbers. Like this, you can insert a table, write down the numbers, then find the digital root and divisible by 9. Yes or no, you can put. That is easy, I think. Right.
Done, teacher.
Right, we'll see the answers. Right, next one, 652. What is the digital root?
13.
Yes. 6 plus 5, 11. 11 plus 2, 13. Then 13 means 1 plus 3. Digital root is 4. Then this number is not divisible by 9. Okay. Next one, 567. Right? 5 plus 6 plus 7. 5 plus 6, 11. 11 plus 7. How much? 18. 18 means 1 plus 8. Digital root is 9. Then this one is divisible by 9. Next one, 856. That means 8 plus 5 plus 6. 8 plus 5, 13. 13 plus 6, 19.
9.
Then 1 plus 9, 20. 20 means 2 plus 0. That is 2. 1 plus 9 is 20. 2 plus 0 is 2. Then that number is not divisible by 9. Then 1143. 1 plus 1 plus 4 plus 3. 1 plus 1, 2. 2 plus 4, 6. 6 plus 3, 9. Then that is divisible by 9. Next one, 1351. 1 plus 3, 4. 4 plus 5, 9. 9 plus 1, 10. Again, you have to add these number together. 1 plus 0, answer is 1. Then this one is not divisible by 9. Next one, 2719. 2 plus 7, 9, 9 plus 1, 10, 10 plus 9, 19. That means 1 plus 9, again 10, that means 1. Digital root is 1. Then this one is not divisible by 9. Then last one, 4536. 4 plus 5, answer is 9. 9 plus 3, 12. 12 plus 6, 18. 18 means 1 plus 8, that means 9. So, digital root is 9. Then, this one is divisible by 9. Okay. Right. Next one. Right, you note down this one, I think. Then this one, examining whether a number is divisible by 9. Now we are going to find out if a number is divisible by 9. We are going to find the method of that, right? Again,
Yes,
sorry,
it's 3 now.
yes, by 3, right? Again, you have to move, that is, there is an activity in your textbook, activity number 2. Complete the following table and answer the given questions, right? First one, number 15. They have given digital root of the number. 1 plus 5. What is the answer? 6. Here answer is 6. Is the digital root of the number divisible by 9? Can you understand that? If the digital root of the number divisible by 3, that means now 6 is the digital root. Is that we can divide by 3? Yes.
Yes.
Then yes, we can put a tick here. Is the number divisible by 3? We already know 15 we can divide by 3. Then answer is yes, I'll put tick. Is 3 a factor?
Yes.
Yes, 3 is a factor, right? We'll do next one also. Here 16. Digital root of the number 1 plus 6. Digital root is 7. Is the digital root of the number is divisible by 3?
No.
7 we can't divide by 3. Then no. The next one, is the number divisible by 3?
No.
Number? No. Then that is also not factor of that, right? Remaining questions I'll keep for you. You can do, then I'll discuss with you.
When, teacher?
Okay, we'll discuss. 24. Digital root is 6. Is the digital root of the number divisible by 3? Yes.
Yes.
Is the number divisible by 3? Yes.
Yes.
Then that is factor of 3. Then 28. Digital root of the number 2 plus 8. That means 10. 10 means 1 plus 0. Then 1. Is the number divisible by 3? No. Then, sorry, digital index is not divisible by 3 and also number not divisible by 3. And 3 is not a factor of that number. 210. 2 plus 1, 3. Then digital root is 3. 3 we can divide by 3. That is correct. Then next one, is the number divisible by 3?
Yes.
Yes. Then factor also. 241. 2 plus 4, 6. 6 plus 1, 7. Then this is not divisible by 3. Then number 241 also not divisible by 3. Then that is not a factor of that number. 372. 3 plus 7, 10. 10 plus 2, 12. 12 means 1 plus 2. Then digital root is 3. Then that is divisible by 3. Then the number 372. Can we divide by 3? Here 1.
Yeah.
Yes. 2. For 12. 4. Then without remainder we can divide. Yes, that is correct. Then 3 is factor of that number. Then last one. 1269. 1 plus 2, 3. 3 plus 6, 9. Then 9 plus 9, 18. 18 means 1 plus 8 again, 9. Then 9 we can divide by 3. Then we'll check whether the number we can divide by 3. Here 4, 12, for 6, 2. Then for 9, 3. Then without remainder we can divide by 3. Then this is factor of that number. So we can get the answers like this. Okay. Then we see what are the questions they are asking. What values do you get as the digital roots of the numbers which are divisible by 3? In other words, the numbers of which 3 is factor. What are the numbers we have got? Huh? 3 as a factor. Here, these are the numbers, no? Here, 6. Then this one, 6. And this one, 3. And last one, this one, right? This one and also this, right? Does 3 always divide the digital root of the numbers which are divisible by 3?
No.
Here, does 3 always divide the digital root of the numbers which are divisible by 3? Here, now you identify these are the numbers which are divisible by 3, right? So, these are the digital root of those numbers. Are those divisible by 3?
Yes.
Yes. Then answer is here, yes. Right? Is every number of which the digital root is indivisible by 3, indivisible by 3? That means they are asking these numbers. Now digital root is 7. Here 1, 3, 1, 7. Are those indivisible by 3? That means they are asking, can't we divide that numbers by 3? Yes or no?
No.
Yes, we can't divide, no? Right? So, what is the final conclusion we can come across? Huh? If the digital root of a number is divisible by 3, then that number is also, we can divide by 3 without a remainder. Got the idea?
Yes.
Right. Shall we note down that also? Here, if the digital root of a whole number is divisible by 3, then that number is divisible by 3. That means that is 3 is a factor of that number. Okay. So you have to remember this one also. When the digital root is divisible by 3, then that whole number is divisible by 3. Note down this one.
Then teacher.
Right. Here, this is the question in your exercise, right? Without dividing, select and write down the numbers which are divisible by 3. Right? Now what we have to do, again you can use that table, prior exercise we have done. Like that you can arrange a table. First two I'll do for you, right? First one, 81. Right? What we have to do is, first we have to check whether the digital root. 81. What is the digital root? 8 plus 1, that is 9. So can we divide 9 by 3?
Yeah.
Yes, without remainder we can divide. Then 81 we can divide by 3 without a remainder. Right? Next one, 102. That means 1 plus 2, digital root is 3. Then this one also we can divide by 3 without a remainder. Then 102 is divisible by 3 and 81 also divisible by 3. Remaining questions for you. Do those. All right.
Then teacher.
Right, we'll discuss the answers. Okay, next one, 164. 1 plus 6 plus 4. 1 plus 6, 7. 7 plus 4, 11. That means digital root
2.
is 2. Then we can't divide this by 3. 189. 1 plus 8 plus 9. 1 plus 8, 9. 9 plus 9. Answer is 18. Then 18, what is the digital root?
9.
9. Then we can divide that number by 3. Next one, 352. 3 plus 5 plus 2. 3 plus 5, 8. 8 plus 2, 10.
2.
That means digital root is 1.
1.
We can't divide this by 3. Then next one, 372. 3 plus 7 plus 2. Answer is 3 plus 7, 10. 10 plus 2, 12. 1 plus 2, 3. Then we can divide this value by 3. 466. 4 plus 6 plus 6. 4 plus 6, 10. 10 plus 6, 16. 1 plus 6, 7. So we can't divide this number by 3. Next one, 756. 7 plus 5, 12. 12 plus 6, 18. 18 means 1 plus 8, 9. So we can divide this by 9. 951. 9 plus 5, 14. 14 plus 1, 15. 15 means 1 plus 5, 6. Then we can divide this by 3. Last one, 1029. 1 plus 2, 3. 3 plus 9, 12. Then 1 plus 2, 3. Then this one we can divide by 3 without a remainder. Okay. Right? Right. We'll move to next part. Next question. Here. I'll do this one and remaining questions I give as homework. Right? 3 divides the number 65 and there is a blank. Suggest 2 digits suitable for the empty space. Can you try that? I'll give 3 minutes. You can try. If you difficult, I will discuss with you. Try to do that.
Okay, teacher.
Right.
Teacher,
Yes, tell me.
couldn't figure out the answer.
All right, we'll discuss. Right? 3 divides the number. They have given 6 and 5. There is a blank. So, if a number is divisible by 3, what we have to check whether? We have to check the digital root. That digital root should be divided by 3 without remainder. Right? Okay? Right? So, here 6 and 5 is there. 6, 5 plus 5. How much?
11.
Yes. 6 plus 5 is equal to, sorry, not 12. 11. Right? So, is 11 we can divide by 3 without remainder?
No.
No. We can write this one as 1 digit. Digital root is then 2. Okay. Yes. So, what are the digital roots we can find without dividing? You can say, what are the numbers we can divide by 3 without remainder? Digital roots we can have only 1, 2, 3, 4, 5, 6, 7, 8 and 9. And also 0 we can have. Right? These are the digital roots, no? We can find. Is that
Yes.
okay? So, if that number is divisible by 3, so we have to check the digital root. We can divide by 3 without remainder. So, what are the numbers we can have? Here, 3.
3.
We can divide that by 3 without remainder. Then 6 and 9. So, now we have here digital root is 2. Then easily we can convert that one to 3 by adding 1. Is that okay?
Yes, teacher.
Right? If I put 1 here, now check 6 plus 5 plus 1. Answer is 12. Sorry. Yes, 12. Okay. Then 12 means 1 plus 2. Digital root is 3. Then that number is divisible by 3. Is that okay?
Yes, teacher.
Right. Then next one, we can convert this to digital index, sorry, digital root. We can convert as 6. Now we have only 2 here. If I add 4, this becomes 6. Right? Now check whether if I put here 4. 6 plus 5, 11. 11 plus 4. 11 plus 4. Answer is 15. That means 1 plus 5, 6 we can get. Then that number also we can divide by 3 without remainder. Is that okay?
Yes, teacher.
Then again we can convert this one to 9. Now we have here 2. Then if I add 7, it becomes 9. Right? Okay. Yes. Then if I write 7 here, 6 plus 5, 11. 11 plus 7, how much? 11 plus 7, 18. 18 means 1 plus 8, 9. So 9 also we can divide by 3 without remainder. Right? So these are the numbers we can insert to the blank box. Right? So what are the values we can write? 651, then 654 and 657. These are the values they are asking. You have to write suitable 2 digits. Then digits are 1, 4, 7. From these you can write 2 digits. Okay, have you got the idea?
Yes,
Right.
teacher.
So remaining questions I'll give for you as homework, right?
Okay, teacher.
Right. Then we have to discuss. Next part is this one. Here we have to examine whether a number is divisible by 6. Then we have to check whether a number is divisible by 4 also. Now time is, I think, 9:17, right? I get late to start the lesson, so I'll wind up the lesson only for today, right? I'll give then covering class for you. Can you do a class in Saturday or Sunday?
Uh,
Discuss with your mother and let me know, right? Then I'll do covering class for you. Then that day I can complete this lesson, right? So remaining questions in the exercises you can do as homework, right? Then shall we meet next day, right? To continue the lesson, right? So good night.
bye, teacher.
Okay, bye.